This demonstration is going to show you the power of the databases that were set up in the previous demonstration and how they can assist users in doing their work. To begin with, the cross-reference database is used for hyperlinking between CAD drawings through the cross-reference bubbles. Let's just choose any random CAD drawing here in a module and take a look at how this is done. This is a CAD drawing here that I've just randomly selected. Let's take a look at the output bubble right up here. If I zoom in on it, you can see that the descriptor text is set at BC-331, etc., etc. If I would like to see where this actually goes as an IREF in an adjacent CAD drawing, I click on it and then right-click and select Item Properties. There's a button that appears in the cross-reference bubble dialog box called View Connections, and if I click this button, the dialog box expands. What's happening here is the cross-reference database is being used to show me where there are matching input references to match this output reference on this page. By double-clicking the entry that appears, I can open up the CAD drawing where it matches and go right to the cross-reference bubble in question. And there's our equivalent IREF. Another good use of the cross-reference database comes into play if I'm adding logic. Take, for example, if I load up any other CAD drawing and I want to attach an IREF to that OREF that we were just working with, I can zoom into the place where I want to place the IREF. Select the IREF button, choose an IREF, and start typing the text that was found in the descriptor of this OREF that we were working with. If I've forgotten what is said in the descriptor text of that OREF bubble, I can type in as much text as I think I'm comfortable with and then click the View Matches button, and it shows me in the database that there are 224 records up to this point that match what text I've put in. But as I continue to type more text, this search becomes narrow, and we're now down to 6 records. And if I type in, I believe, the last character here, there is our OREF bubble that we're working with. To add it into the IREF that we're going to add, right-click on the grid and copy the descriptor text, and it makes a perfect match. Click the OK button and drop in the new IREF. So that's a simple example of how the cross-reference database works. Let's take a look at the function block database. Function block database is a little more in-depth and detailed than the cross-reference database. There is a user interface here where users can perform either a SQL search or a quick search on the database. To explore this, let's take a look at the quick search. And let's say you've got a plant manager who comes up to you one day and says, okay, I'd like to know exactly inside our system here how many PID loops we have. I can quickly interrogate the function block database and say, okay, I'm going to look at every function code 19 that's inside this project. So I type in function code 19, click search, and it tells me that we've got 86 records. I can double click on any entry that appears in the grid here, and it'll automatically load up the CAD drawing and take me right to the block. Now, function code 19 is one type of PID block, but what happens if they've got advanced PID blocks such as 156? If I click on that, I now have 286 records. So I've got a combination of simple PID and advanced PID function blocks being used in this project. What happens if I want to query for both type? Well, I can switch over now to the SQL search, and you can see here the SQL commands that were copied over from performing the quick search for function blocks type 156. And if I'm good with SQL, I can add to the actual SQL and specify all of function block types 156 or function code 19, and this should expand if I click the execute button. It's now got 372 records. So if I scroll down, there we've got a few function codes 19 and 156 in here. Once again, users can double click on the grid. It'll take you right to the block in question. And there it is. Which block was that? If I press Control F on the keyboard, I can quickly see when I'm zoomed out which one that I was working with. That Control F stands for flash, and that will draw a red rectangle 3 times around the block that I was working with. Jumping back to the function block database, now that I've done the SQL search here, there's a button that appears called Print Report, and this will generate a report that you can use to send off to a printer, or you can export this out as a CSV file or as an HTML file by clicking the Save button. And your various types that you can export this report as are specified in the Save As Type box. But then you can print this off and hand this off to your manager and say, okay, these are the locations of all the PID blocks that are inside our system. Moving over to the graphics database. The graphics database, really not too much use for it other than for just querying and showing what tags are being used in what graphic. The beauty of this, though, comes into play when we start working with what's known as the tag interrogator. And this tag interrogator brings together all of the databases that we've been working with up to this point. So click on the tag interrogator. Users can type in the name of a tag, and I'll work with this one that we were working with, and click the search button, and it will pull the databases for the tag information, the graphics information, and then it will also read the configuration file information for every single configuration file that is stored in the same module where this tag lies. Double click on the results for the tag database. It'll open up the CAD drawing and take you right to the tag in question. If I go back and click on the graphics database results, it'll take me right to the display that is using that tag, and there it's flashed again as well too. It will already have been identified as well too if you're jumping into a display or a CAD drawing from the tag interrogator, so users can just quickly right click and take a look at the item properties. And once again, if I'm zoomed out and if I want to know which one that was, I press Control F on the keyboard and it gets flashed for quick identification purposes. Now if I'm working with any graphical element that has a tag in it, there's a little button that will appear that looks like a CAD drawing. If I click on that, it'll take me right to the CAD drawing where that tag is located. Likewise, if I'm in a CAD drawing and I'm working with a tag, I can also right click on it and take a look at the item properties. There's a button that appears that looks like a screen. Click on that and it'll query the graphics database showing you where that tag is used in every single graphics display. Let me go to a better one here. Okay, so let's jump out of this and go back into the graphics database for a second. There's one last thing that needs to be demonstrated, and that is the ability of auditing the graphic tags. This procedure performs a SQL comparison of the tag database versus the graphics database. And this will locate, if I click the Start Auditing button, every single entity inside the graphics that contains tags. And if there is no tag name located inside the tag database, it'll be flagged and indicated in this procedure. Now this can take a few minutes to run, so I'm going to magically pause this demonstration and restart the demonstration after it is finished. Now that the auditor has finished, let's take a look at what it has found. In this example, which by the way took about 6 minutes to perform, it located, I think it's over 4,000 instances where there were no tags found inside any of the graphics. So we can double click on any of these entries. It'll automatically load up the graphics editor and take us to the item in question. Users can then right click and take a look at the item properties. And if I try to click on the show tag in the CAD drawing button, it comes up with an error message that the tag name was not found inside the tag database. So the auditor has performed its duties and has indicated to us all the graphical entities inside every single display file that need to be touched up. And users are free to save this log, or they can load in the log again if they want to work with it and bypass the step of having to reperform the audit every time. So that basically concludes this part of the demonstration. We'll get into some more of the advanced features in later demonstrations.